Newton's first law, it basically states that if a body is at or moving in a straight line or constant speed, it will remain at rest until acted upon by a force. In this example that we did with the tablecloth, since we pulled the tablecloth really fast, and the objects are basically lazy, meaning that they don't really want to move, the object stayed stationary for the most part. The cones and magazines did move a little, but that was just because of a little bit of friction. If you look at the utensil holder though, it basically remained in the same position. So another part of Newton's first law is inertia. And inertia is a body's ability to resist motion. And you kind of already know about this, but you probably didn't put it into words like Newton did. So, for example, if I gave you these two objects and said which one was heavier, you would probably move your arms up and down like that. And since you're doing that, you're seeing which one resists the most motion, which means that it would be heavier.
In the formula, force is equal to mass times acceleration. Force is directly proportional to mass and acceleration. What that means is the more mass or acceleration something has, the more force is applied to the object. So in the two videos, one of me just tossing the piece of ice at the wall and one of me chucking it at it, the one where I just toss it will have much less force than the one that I throw it, because one has more acceleration and one has less. Same mass, different mass of acceleration.
When two bodies interact, they apply forces to one another. That force is equal in magnitude and in opposite directions. For every action, there's an equal and opposite reaction. The same concept applies when we threw the ice at the wall. The ice breaks because the wall gives the same amount of force back to the ice cube. That force that the wall gives back is enough to break the ice and shatter. That's why you saw the ice break and the wall didn't.